Fluorouracil and flucytosine are both antimetabolite drugs used to decrease DNA synthesis, and they do this by decreasing the free amount of thymine. Fluorouracil is primarily used for cancer, whereas flucytosine is primarily used for fungal infections. And you can see on the HPLC here that fluorouracil and flucytosine are both very similar drugs. And if you look at the chemical pathway and the mechanism of action once it's intaked into the cell, they're very similar. So we have the fungal side here, and the important distinction to make here is that cytosine deaminase is only found in fungal eukaryotes. Whereas 5-fluorouracil can be also taken up by fungal cells, but the issue is that 5-fluorouracil is a very, very effective anti-cancer treatment. And this is because it inhibits DNA synthesis. But one issue with the inhibition of DNA synthesis is that it's systemic, meaning that all cells in the body that have a high turnover rate would be affected. So we have a strong contraindication with myelosuppression with 5-fluorouracil. And for this reason, when they were developing flucytosine, they wanted to create a highly specific drug only for fungal infections. So they were able to find that cytosine deaminase was associated with this pathway. And that distinction is very important. Otherwise, these drugs, the entire pathway is the same way, where we're just trying to decrease the free amount of thymine in the de novo production. And just to reiterate that, thymine is a very, very hard nucleotide relatively to the other nucleotides to produce. And so we have to have this intermediate step where we produce DUMP, and this is exactly what fluorouracil and flucytosine inhibit. So just to summarize, fluorouracil is a more raw form of the drug used systemically to fight cancer, whereas flucytosine is the exact same drug, but with a prodrug aspect that makes it highly specific for fungal infections.